Good day, class. Today I'm gonna teach you how to solve linear programming using Simplex method. I am Engineer Nicholas C. Bano, your teacher. These are the following steps in solving linear programming using Simplex method. First, represent the unknown in the problem. Second, tabulate the data about the facts if necessary. Third, formulate the objective function and constraint. Fourth, convert to a system of linear equation in standard form from your equation in step 3. Step 5, we're going to set up now our initial table. Step 6, select the pivot column. Step 7, select the pivot row. And then step 8, we're going to identify the pivot element out of our step 6 and 7, identifying our pivot column and pivot row. And that is our pivot element. Later on then, we're going to compute the values, eliminating them. We're going to compute our pivot element will be setting up equal to or number 1, and the rest of the column will be 0. Then after that, step 9 will be, we're going to repeat the values set up from the table. We're going to compute the new values repeating from step 5 to 8. Then step 10 is we're going to make a decision. So this is decision to be made. But before that, we're going to identify first the rules of types of constraints. For greater than, equal to constraints, this is subject for slot variables. We're going to add slot variables and artificial variables. So in this case, we're just going to put an S and A for artificial. S for slot variable. And for lesser than equal to constraints, we're going to add only slot variable. That is S. And for equal constraints, this is just we're going to add artificial variables such as A. To have this linear programming, we're going to have an example. This is an exercise. Okay, we have a word problem. A small firm that confirms that assembles computers is about to start production of two new types of personal computers. Each type will require assembly time, inspection time, and storage space. So we have here the three constraints that we're going to consider: the assembly, inspection time, and storage space. The amount of each of these resources that can be devoted to the production of the computer is limited. So the availability resources here should be considered. So the manager of the firm would like to determine the quantity of these computer to produce in order to maximize the profit generated by sales of these computers. In order to develop a suitable model of the problem, the manager has met with the design and manufacturing personnel. As the result of of the meeting, manager has obtained the following information of data below. We have here for type 1 and type 2. So these are the considerations that we're going to have. The profit per unit, assembly time, inspection time, and storage space per unit. So we have here for type 1, $60. And assembly 4 hours, 2 hours for inspection, and 3 cubic feet with the storage space. Although type 2 the same with the storage space. But the profit is less than the profit of the type 1, which is 50. But it has longer hours compared to our assembly time. And we have only 1 hour for type 2. The manager has also acquired information of the availability of the resources, the company's resources. These are the amounts below. We have here the resources amount available per day. So the assembly time, we have 100 working hours only. Inspection time, we have 22 working hours. And storage space, we have 39 cubic feet. The manager met with the firm's marketing manager and learned that the demand of the computers was such that whatever the combinations of these two types of computers can be produced, all the output can be sold. So to do this, we're going to follow the steps. So we have here step one, represent the unknown in the problem. That means we're going to identify first our variable here, in which is we're going to let x is our type 1 computer and y is our type 2 computer. Second step, we're going to tabulate the data about the facts. So out of the given information or data, so in order later on for our step 3, so that we can just make it easy for us to make our equation. So in our first column, we have here the resources. Okay, so we have here the profit, assembly, inspection, and storage. The second column, we have here the type 1 and data, and type 2 in the third column, and the last column is our availability. Okay, the profit is 60, assembly 4, inspection 2, storage 3. This is just the same from our data, so we're just simply tabulating our data or informations as like this, wherein the availability initially here for our profit is 0. So it is none because still we're going to compute it. For step 3 now then, after our we tabulated, we're going to formulate the objective function and constraints. So this is how we're going to formulate our equation. So our objective function, this is a maximization because we're going to maximize the profit. So in which is based from the equation, it is P is equals to 60x plus 50y. X for our type 1 variable computers, that is the price at 60. And we have here our type 2, the price is 50. And we consider as Y as our type 2 variable. Okay? And for our subject to constraints, so we have here for X for type 1, and for type 2 we have 10Y. Then this is less than equal to 100 only. Because our variables here of our computers for assembly time cannot be more than of the available resources of our assembly time. And the same thing will happen with our inspection time. We have 2x plus y, which is also be less than equal to 22. Also, with our storage space, we have here 3x plus 3y, the same space with type 1 and type 2 computers. So that is less than equal to 39. Then of course, we're going to do not forget to show or include our non-negative constraints, in which is we have here our x is always greater than or equal to 0 only, as well as our y is greater than or equal to 0 only. That is to avoid negative values. So we have here our step 4 now. Out of the given equations from our objective functions and constraints, we're going to have our new objective functions and constraints in standard form of equations from our linear equations. So the standard form will be like this. So I have here our new objective function. So we're going to align all the data for x, for y, and of course we have three constraints here: our assembly, our inspection, and our storage space. So then that means we're going to have three slack variables. Okay, for each constraints specifically assigned for, let's say for example for assembly, so that means that is assigned for assembly. For inspection, that is assigned for inspection, and for storage space, that is assigned for storage slack variable. Okay, so I just write SA, that means slack variable for assembly. SI here, that means that is slack variable assigned for inspection, and SS here, assigned variable for storage space. Okay, initially our profit here has no value for slack variables because this is equal to, in which is our artificial variable here we use is the P. Okay, then our constraints, we have here three constraints. So the first equation here to be written in standard form. So that means we're going to follow, align all the variables for x here, for y here, for SA. That means for slack variable for assembly, slack variable for inspection, slack variable for storage space. Okay. So we have 0 for inspection here, 0 for storage space because this is assigned for assembly slab variable. Okay, the same thing will happen with our second equation. We have here 2x plus y plus this is now 0 for our slab variable for assembly because this is assigned for slab variable for inspection. Okay, the same thing will happen with our, oh sorry, this is si. This is si. So let me just edit this. So that is si. That is not si, that is ss. Okay, then let's go back. Okay, that is ss, which is equal to 22. Okay, in a standard equation, we're going to replace our inequality symbol with an equal symbol, in which is the right side here, okay, will be constant value. Okay, so all the variables will be in the left and all the constant value will be in the right. Of course, our profit here, objective function, has zero value since we don't have a constant value here. Okay, the same thing will happen with our third equation. We have here 3x plus 3y aligned with our x, y, and as well as our assembly slack variable, inspection slack variable, that is 0. So this is assigned for storage space slack variable. So that is why our storage space variable here is 1. Okay, take a look of the coefficient in which is, okay, we have here 0 for the second equation, 0 for storage space for the second equation, because this is specifically assigned only for inspection slab variable. Okay, later on we're going to write it properly. We're going to align so that we can have our initial table properly. Okay, out of that. So also we are going to declare our non-negative constraints, in which is our slab variables also can be should be included. Okay, in which is our slab variable should be greater than equal to 0, so that the same with our inspection and storage space, so that we're going to avoid any negative values of our slab variables. Okay, that means if it will happen that our slab variables will have a negative value, that means it will not be included to our solution. Okay, but although it is still the part of our equation. Okay, now step 5, set up the initial table based from our equations. We have now our new objective function, our new equation. So in standard form, we have here to set up our initial table. It will be now like this. We just delete slack variables in which is 0. So we have now slack variable given for assembly, for inspection, and for storage space. So specifically that has a value coefficient with 1. Okay, so for our initial table, this will be like this. We have here the first column, our basic variable, BV there, that means basic variable. We have here our second column, which is X variable. This is our main basic variables, X and Y. So the third column here, this is our Y. And the fourth one, the fifth, and the sixth, we have here our slot variables for assembly, inspection, and storage space. And which is the last column right here. This is our availability or available resources, or we call it RHS, which means right hand side. Okay, so we have here for our row 1 right after our variables right here. So this is intended for our uh, slot variable for assembly. So we have here write the assembly slot variable. Then also we have here our slot variable for inspection, S, and our slot variable for storage space, SS. Okay, the same thing with our profit. The profit will be just down below after all the slot variables. So we have here P, our objective functions. From the top, our objective function right here, we're just going to write it below from our in our initial table. Okay, so together with, we're going to align all the variables for X, all the variables for Y, all the variables for SA, slot variable for assembly, slot variable for inspection, slot variable for storage space. So then the following data we have here for negative 60, for p that is negative 60, we're not going to copy our variable x since this column right here is for our variable x. Okay, negative 60. For our SA we have here 4, for SI we have here 2, for S we have here 3. The same thing with our y. We have here negative 50. So down below we have here p. This is in the third column, which is a y column. We have here negative 50. Okay. So for slug variable assembly, we have here 10. We have here y10. So y is 1 right here. And our y here for the third slug variable, which is 3. So slug variable here, since we don't have the value for our profit, so that is 0. We have here the value for our slug variable, so that means we have here 1. Same thing with our SI 1 here, SS 1 here, and the rest of the slug variables here, okay, which is not included, so that means we have here a 0. So 0, 0, then 0 for SA, 0 for SE right here for our SS, SI here 0, so we have your SA and to SI 0, SASS that is 0. So for our availability or available resources right here or right hand side, we have here for slug variables for assembly, this is 100. For inspection, we have here 22 available only. And for the storage space, we have here 39. And of course, our P right here, that is 0. So this is how we're going to set up our initial table based from our standard equation, okay, of our linear equation. Then we're going to have our step 6, in which is we're going to select the pivot column. So this is how we're going to select the pivot column. The pivot column in this table is that it will be based on the profit, in which is it is the lowest value or negative value. Okay, so between negative 60 and negative 50, negative 60 is the lowest value among the two. Okay, it is actually the most negative value. Okay, so we choose now our column X right here as our pivot column. Okay, step 7 now, we are going to select our pivot row. So to determine the pivot row, this is just simply we're going to use, okay, I colored here yellow, and which is actually that is our pivot row. And which is actually we base it from our, we add another, actually we just add a temporary column right here, which is we call it exchange ratio. I put here ER. ER means exchange ratio, in which is exchange ratio is equal to our right hand side or available resources divided by our chosen pivot column, in which is in this case, okay, in this row for assembly, we have your 100 divided by our pivot column, which is 4. So that is equal to 25. The same with our second row, we have here 22 available divided by 2, in which that is 11. And we have here 39 on our third row divided by 3, and that is 13. So out of the given, okay, if actually we're going to include the profit right here, in which is that is initially 0, if you're going to divide 0 by any number, actually in the exchange ratio it cannot be 0, and also it cannot be negative. It should be the smallest positive values. In this case, we have here the smallest positive value is the second row. That is the inspection row. Okay, slug variable inspection row. Okay, so let's just say that SA or assembly is our first row, SI is second row, SS is the third row, and our P or profit is our fourth row. Okay, so then we choose our second row or row 2 as our pivot row. Okay, once we determine the pivot column and the pivot row is out of our, we determine from our exchange ratio, which is the smallest value, positive value, then we can now identify our pivot element, in which is the pivot element, okay, is the cross section between our pivot column and our pivot row, and which is in this case we mark it here red, that is number 2. So after we identify our pivot element, our objective there is we're going to make it equal to 1. So we identify here 2 as our pivot element. Then we're going to identify also our entering variable. That means it is actually our entering variable is our pivot column variable, in which is x. Then we are also going to identify our exiting variable, in which is the slack variable or the temporary variable si, that for inspection. We're going to exit that. That means we're going to replace that with x. So the new table here, as you can see in the second row, we replace our si with x. So that is now we have here x and x. So in which is also I told you earlier that the pivot element, after we identify whatever the value of our pivot element here, we're going to equate it or make it equal to, compute it equal to 1. Okay? So in this case, our row 2 just simply to divide the value by itself in order to make it 1. Okay? So the formula for our row 2 right here is just simply we're going to divide it by 2. So to divide this by 2, that is 1/2, we're going to multiply it 1/2 or divide it by 2, that is still the same. We're going to multiply R2, okay, with 1/2. So 2 multiplied by 1/2, that is equal to 1. 1 multiplied by 1/2, that is 1/2. 0 multiplied by 1/2, that is 0. And we have here 1 multiplied by 1/2, that is 1/2. And 0 multiplied by 1/2, that is of course 0. And 11 divided by or multiplied by 1/2, that is equal to 11. Okay, we're done with our R2. Next, we're going to do now our R1, followed by R3 and R4. So don't worry, later on we're gonna have our solutions after this slide. So the formula for our R2, okay. So since this is the highlighted yellow here, the second row, this is our new value. So in which is we call it also row new 2. Okay, I just write it row new 2 in order to identify that this is actually my new values for my row 2. Okay, so I just put it row new 2. So as I've told you earlier also, our pivot column, once we convert our pivot element equal to 1, and the rest of the value of our column will be equal to 0, except the variables, of course. Okay, I'm talking about the values only. So the value here 4, we're going to equate that 0. The value here 3 equate to 0. And the value here equate to 0. Okay? So how we are going to make our formula? Our formula will be based on our new R2. So it will be always like, if we're going to compute our R1, so we're going to write here R1. For our R2, so we're going to write here R3. For R3, sorry. For R3 or row 3, we're going to write here R3. Okay? For R4, we're going to write here R4. Then we're just going to process. Okay, whether we're going to subtract or add. Okay, it depends on the value of our variables right here. Say for example, you have here 4. Since the new values of our row 2, which is 1, so that is just then we're going to simply multiply 1 by any values of this in order to make it 0. Since this is 4, 1 times 4, so that means that is why we're multiplying our row 1 with row new 2 with our 4. Okay, so that is done. We're going to multiply 4 times 1, that is 4. So our first value of our row 1 here is 4. So 4 minus 4 times 1, that is equal to 0. Okay, so next, we're going to multiply here. This is 10. 10 minus 4 times, of course, our new row new 2, that is 1/2. So 4 times 1/2, that is 2. Okay, 10 minus 2, that is equal to 8. Okay, so next, again, let's do this. R1. Okay, for column SA, we have our SA is 1 minus 4. But of course, we're going to multiply that with our row new 2, which is equal to 0. So 4 times 0, that is 0. But of course, we have here the value 1. 1 minus 0, so that is equals to 1. Okay, same with our SI. SI here, we have here 0. 0 minus 4 times, we have here 1/2. So 1/2 times 4, that is 2. But of course, our R1 here is 0, so that means 0 minus 2, that is simply equals to negative 2. Okay, so the same thing will happen with our slot variable S column. We have here S, the value for row 1, which is 0. 0 minus 4 times our row new 2, which is also 0, so that is why it is 0. So our last column for our available, our right hand side column, we have here 100. 100 R1 value minus 4 times, of course, our row new 2, which is 11. So 4 times 11, that is 44. 100 minus 44, that is equal to 56. Okay. Same thing will happen with our row 3. So the same process, I multiply my row new 2 here with 3 in order to eliminate the value of 3 right here. Okay, from our previous, okay, original value of our slot variables row for SS. Okay, so this is now the third row. So R3 minus 3 times R new 2. This is my formula. So to process this, we have here R3, which is 3, just to show, okay, how does the new values actually perform, okay, the operations. We have here R3, which is 3 minus 3 times our new R2 is 1. So that is why it is equal to 0. Okay. So next column at Y, we have here 3, our value. So 3 minus 3 times, of course, our new row 2 value, which is 1 half. So 3 times 1 half, that is 3 halves, or 1.5 in decimal. Okay. So that means 3 minus 1.5, so the answer that is 1.5, or 3 halves. Okay. So next, that is 3 halves. So next is column assembly. Okay, slack variable for assembly column. We have here the value is 0, but also the value here is 0, so that means 0. So 0 R3 minus 3 times 0, so that is 0. For slack variable SI, we have here SI also is 0, minus 3 times our new value of our row new 2, which is 1 half. So 0 minus 3, 1 half. So that is negative 3 halves. Okay. So next, SS, or column SS, or slack variable for storage space, we have here the value, which is equal to 1. 1 minus 3 times our new value is 0, so that is now then is equals to 1. Okay. And sorry, we have here the right hand side column, the value, the original value, which is 39. 39 minus 3 times the row new 2 value, which is 11. So 3 times 11, that is 33. 39 minus 33, that is equal to 6. So last column, last row, we have here the fourth row. So you have here R4. R4 plus, I add here 60 because the value of my variables right here in our X for profit, that is negative 60. That is why I add 60. So this is now my new formula because our new value here, it is equal. You remember that it is equal to 1. That is why we equate it into 1 so that whatever the value of our coefficient here, we'll just simply multiply it with the same value of our, we're going to eliminate it to equate it to equal to 0. Okay, so let's perform it. R4, which is negative 4, negative 60 plus 60 times R new 2, which is 1, so that is 60. So negative 60 plus 60, that is equal to 0. Okay, next at column Y. So column Y, we have here negative 50. Negative 50 plus 60, but of course our row new 2, which is 1 half. So 1 half of 60, or zero point 0.5 times 60, that is 30. So we have here negative 50 plus 30, so that is equal to negative 20. Next, we have here for our slack variable assembly column, we have here 0, 0, R4, so plus 60 times, also the value of our assembly is 0, so that is why it is equal to 0. Next column, inspection slack variable column, we have here the value of profit column, or row 4, we have here 0. 0 R4 plus 60 times our new R2, which is 1 half. So 60 times 1 half, that is 30, but of course our row 4 here is 0. So 0 plus 30, that is equal to 30. Next, slot variable storage space column. We have here the value, the original value is 0, plus 60 times the new R2, which is also 0. So that is why it is just simply as 0. Last column, or available. We have here 0, 0 original value of our profit. We don't have a value, so that is 0. Plus 60 multiplied by our new R2, which is 11. So 60 times 11, that is why it is equal to 660. Okay, after all of the steps 6, 7, and 8, we have now our new values for our new table. Okay, so out of that table, that is, we consider that as a new initial table. So this is the solutions lately, just to show you. From row 1, we multiplied by 1 half. Row 2, we uh, subtract it, we multiply our new R2 with 4. The same with R3, row 3, multiplied by 3 in order to eliminate 3 here. And with row 4, okay, just go over, review this process. That's what I've discussed earlier. Okay, this is the whole process solution. The solution of our table. Okay, so let's just skip this. Next, step 9. So step 9, we're going to repeat these steps. Step 5 to 8, in which is actually we're going to rewrite again our new initial table, which is, we just copied our new table right here. So in which is, in step 6, we're going to repeat step 6, which is to find our pivot column. Our pivot column here, since the column y right here is already 0 and we don't have any negative value right here, which is only 20. We cannot consider our slot variables right here, slot variable for assembly, slot variable for inspection, and slot variable for storage space, because they're not really the main basic variable, in which is the main basic variable right here is only x and y. So that is, now we don't have any other choice, but we choose our pivot column y as our pivot column. Okay, this is our pivot column, step 6. Then this is our step 7, find our pivot row. To find our pivot row, of course, we're going to have our temporary column here, our ER, or exchange ratio. So that is, we're going to divide our new values of our RHS here divided by our pivot column. And which is, in this case, we have your 56 divided by 8, that is equal to 7. 11 divided by 1 half, okay, that is actually 22. And we have your 6 divided by 3 halves, that means 2 times 6, that is 12 divided by 3, that is equal to 4. And next here, we have your 660 divided by negative 20. That is not actually equal to 0. That is actually negative. Okay, but of course, just write there 0. So that is actually nothing. Sorry for that. I have to change that. Hold on. So we don't choose negative values. So that is why it is not actually 0. That is actually negative. Okay, as I've said, in our exchange ratio, we're not going to include the negative value, but we're going to choose the smallest positive value only. Okay, in this case, we have here row 3 as our smallest positive value. So that is why we choose our row 3 as our pivot row. Once then we identify our pivot column and pivot row, then the crossing, okay, the crossing value right here, which is 3 halves, is our pivot element. So step 8 is we're going to identify our pivot element, and entering variables is y because that is our pivot column variable, which is y. We're going to replace our slot variable ss because that is now existing variable. We're going to replace that with our entering variable, which is y. Then after that, so we're going to process compute. We're going to set or make our pivot element equal to 1. So in order to make that equal to 1, so that means we're going to reciprocate the value. We're just simply multiply it by, that is 3 halves, so we're going to multiply it by 2/3. Okay, so row 3 then, just simply we're going to multiply it by 2/3. So our new value here, for our new table, we have here 0 multiplied by 2/3, that is of course 0. 3 halves multiplied by 2/3, that is equal now to 1. And 0 multiplied by 2/3, that is 0. We have here negative 3 halves multiplied by 2/3, so that is negative 1. And 1 multiplied by 2/3, that is equal to 2/3. And we have here 6 multiplied by 2/3, that is 12 divided by 3, that is equal to 4. Okay, so next we have here row 1. Let's do our row 1, new value here. So how did this happen? Okay, how does this change? Okay, we have here row 1, the original value is 0. So as I've said, okay, to formulate this, we're going to write row 1 here. Okay, for row 2 here. Okay, and the first, okay, on the right side of our formula, and row 4 here. Then we're just going to add or subtract. Okay, in this case, since the value here is positive, then we're going to subtract 8. We're going to multiply with our row new 3, which is equal to 1. Okay, sorry. So row 1 here, we have here R1 is 0 minus 8 times 0. So that is y equal to 0. Next, we have here column y. Column y is 8 minus 8 times our row new 3 is 1. So that is why it is equal to 0. That is 8 minus 8, that is equal to 0. Next, column SA, slack variable assembly. We have here the original value is 1. So 1 minus 8 times, of course, the new value is 0. So that is why it is just simply equal to 1. Next, column SI. So SI, we have here the original value negative 2. So negative 2 minus 8 times our new value of our row new 3 for SI is actually negative 1. So if you're going to multiply negative 1 times negative 8, that is positive 8. But of course, our row 1 right here is negative 2. So negative 2 plus 8. So that is why it is equal to positive 6. Okay. Next, column SS, slack variable for storage space. The original value is 0. And we're going to subtract it by 8 times our row new 3 value, which is 2/3. So that means we're going to multiply 8 times 2 divided by 3. So that is why it is negative 16 over 3. And of course, we're going to do now our right hand side value, which is 56. So we have here 56 R1 minus 8 times our row new 3, which is 4. So 4 times 8, that is 32. 56 minus 32, so that is why it is equal to 24. Next, we have here our row new 2. So simply we subtract it with our R3 multiplied by 1 half. So that is 1 half multiplied with R3 in order to eliminate 1 half right here, so that it will be equal to 0. Okay? So the formula here R2 minus 1 half, but of course the value of our row new 3 here is 0. So that is 1 half times 0, that is 0, which is 1 minus 0. So that is why equal to 0. Next, we have here 1 half R2 minus 1 half times your new R3, which is 1. So that is 1 half times 1, that is 1 half. So 1 half then minus 1 half, that is equal to 0. Okay? Next, we have here the value which is equal to 0. 0 here are new 2. But of course, our SE right here also new R value, which is also 0. So that is why our column assembly is also equal to 0. Next, we have the original value 0, but we're going to subtract it 1/2 times the new value, which is the new value right here of our SS, which is actually 2/3. So that is why if you're going to multiply it, 2/3 times 1/2, that is now equal to 2/6, or that is why it is just simply equals to negative 1/3. Okay, next, RHS column, we have here the original value 11. So how does become 9? So 11 minus 1/2 times row new 3, which is 4. So that is why 4 divided by 2 or multiplied by 1/2, that is equal to 2. So 11 minus 2, that is why it is equal to 9. So we have here our final value of our x, which is 9. Okay. Next, row 4, last row. We have here row 4 plus add 20 times row new 3. We add here 20 because the value of our profit here in column Y is negative 20. That is why we add 20 in order to make it equal to 0. Okay, so to perform that, we have your R4, which is 0 plus 20 times, of course, our row new 3, which is 0. So that is why it is equal to 0. Here next, we have your negative 20 plus 20, but of course, our row new 3 here is equal to 1. So that is why negative 20 plus 20, that is equal to 0. Okay? Next, column SA, we have here 0 and another 0 for our row new 3, which is 0. So that's why our profit column SA is 0. Next, SI. So SI here, we have the original value, which is 30. But 30 plus 20 times, we're going to multiply it with our new RT, which is negative 1. So that's why negative 1 times 20, that is negative 20. Negative 20 plus 30, of course, then that is 30 minus 20, that is equal to 10. Okay, next, column SS profit, we have here the original value is 0 plus 20 times multiplied by row new 3, which is 2/3. So that's why 20 times 2/3, 20 times 2, that is 40 divided by 3. So that is why the value here in fraction, we have here 40 over 3. Okay, and last, we have here the right hand side column, 660 original value, profit column RHS or available. We have here 660 plus 20 times our row new 3, which is 4. 20 times 4, that is 80. Right? 4 times 20, that is 80. Plus 660, that is why it is equal to 740. And this is our last table, in which is we may now identify our x value and y value actively. So that is, as you can see, we have here a line x column and column and row 1, and y right here column at 1. So that means it is now our value, which is equal to 9, and y is equal to 4. And our profit here, or maximum, okay, which is 740. And that is why in our step 10 right here, sorry, this is our solutions of from our table. So just kindly go over, just review the solutions from the PowerPoint I've posted in our LMS. Okay, so this is, we just simply multiplied by 2/3 in order to make our pivot element equal to 1, since the value of our pivot element is 3/2. The same thing happened with the rest of the column. Since we're going to our objective, we're going to equate it, we're going to replace it or equal to 0, so make it 0. So that is why we multiplied R1, R2, R3. We subtract and add. Okay, it depends on the value. In this case, we subtract it by 8, which is our new 3 here is 1. Okay, 1/2. times 1, 20 plus times 1. So that is why negative 20, that is 0. 1 half minus 1 half, that is 0. 8 minus 8, that is 0. So this is how we are going to make our solution. Okay, just review the solution. So let's just go now to our final step, step 10, decision making. So the decision is to be made here. Okay, this is the last table, copied from the last table, in which is the value of our x right here and y and p here. We have here 9, 4, and 740. So we use this now as our final solution. We have here profit maximized at 740 and the solution, okay, at x is equals to 9, y is equals to 4. Okay, so the same thing from our graphical method, just to show you, I made a solution just to show that the solution is still the same even if you're using graphical method. Okay, this is the solution. Okay, we replace our inequalities with equal symbol. We have here the first constraint, second constraint, and third constraint. These are the values. Just review the PowerPoint in which is I posted in our LMS. So these are the following solution. Okay, just take a look or follow the solution. In this case, all the inequalities is less than equal to, so that means all the arrows is going left or going down. Okay, so in this case, we identified now our feasible region as this one. Okay, and these are all the values right here. Okay, so we identify here 9 and 4. That means this is our, okay, this is our final solution, in which is this is our maximum value. Okay, at x is equals to 9 and y is equals to 4. Okay, thank you.